Here's a presentation on kinetic energy. There's a GCSE question at the end, and you can pause the video, have a go at the question, and then there'll be the answer as well. EKE or KE, the units are joules. The equation K equals a half mv squared. It's for an object moving with a velocity v. The faster the object's moving, the more energy it would have. Also, the more mass it has, moving at the same velocity, the more energy it would have as well. So the two terms are mass, which is in kilograms, and velocity, which is in meters per second. Let's have a look at a question. A ball of mass 500 times 10 to the 3 kilograms is dropped from a height of 1.0 meters. What is its speed as it hits the floor? Pause the video now if you want to have got the question yourself, or carry on and I'll go through how to go out about the answer. So first of all, let's draw what's happening. We've got a ball, it's at a meter height, and it's going to be dropped towards the floor, and just before it hits the floor it will have a velocity v. For this we're going to need to use the law of conservation of energy. We need the energy at the start will equal the energy at the end, and when we know the energy at the end we can work out the v term. So the energy at the start is gravitational potential energy, and it equals mass times gravity times height. Now there's a few things in the question done to trip you up. The more fast working pupil might just write 500 for the mass, which would be wrong. It's 500 times 10 to the 3. So if you slow yourself down a little bit, you'd get this correct. 500 times 10 to the 3 is 0.5. So it's 0.5 kilograms times gravity, which is 10, times the height, which is 1.0. So that's 1, which equals 5 joules. Now, using the law of conservation of energy, the energy at the end will equal the energy at the start. The energy at the start was gravitational potential energy. The energy at the end will be kinetic energy. So I now need to write in KE equals a half mv squared. That's the equation that I'm going to use. So I put the terms and I put the numbers directly underneath the terms so I can't make any mistakes. So K equals 5 equals a half. The mass was 0.5 v squared. Now I can multiply this part out and I'll get 5 equals 0.25 v squared. Now what I need to do is move the 0.25 from that side to the other side, and I'll get 5 divided by 0.25 equals v squared. So v squared equals 20. So that's how many 0.25s are there in 5. V squared equals 20. V equals the square root of 20. And I need to use my calculator now. I use my calculator and I get the answer of 4.4721359. And I'm going to stop there. I could write more because there's more numbers on my calculator, but I won't get the marks, and this is the reason why. I'm claiming an accuracy with this answer. I'm claiming that I am accurate to the nearest tenth, the nearest hundredth, the nearest thousandth. Oh, I'm now working to an accuracy of 10,000th, 100,000th, millionth. That's now an accuracy of 10 millionth, and there an accuracy of 100 millionth. I'm nowhere near that accurate. So what accuracy should I use? Well, coming back to the question, here we have an accuracy of 1.0 meters, which is 2 significant figures. So my answer should be to 2 significant figures. Just pause the video, see if you can work out what it is to 2 significant figures. So you should have got 4.5 meters per second when you put the units on the end. So where are the marks for this question then? I'll just go over them. We've got 1 mark for the energy at the start. We've got 1 mark for the equation. We've got 1 mark here for rearranging the equation. We've got 1 mark here for the correct answer to the correct number of significant figures. And we also have a mark here for meters per second. So we've got 1, 2, 3, 4, 5. 5 marks. Okay, so that's out of 5 then. Oh no, 1 here for the substitution as well. So that's out of 6. So well done if you got all 6 marks out of 6. And that's the end of the presentation.